Okay, hello everyone. So we're about to start proofs by induction, but before we go deep into that, first of all, let's start with this question that says generate the formula for the sum. So it's important that, in fact, before we do any of this, we understand what a summation is, right? When we have to understand what a summation is. So, say for instance, so we're just going to have a quick video on summations before we even start with this. So, say summations, right? Summations. What are these guys? So, say for instance, I have something like S is equal to 1 plus 2 plus 3 plus 4 plus 5, right? I wanted to represent this. So a sum is basically a shorthand way of representing this series here, right? And then for summations, we use the sigma symbol, which is this guy over here, right? And then what we do over here, on the top, we put the number of terms that we have. In the case of our S here, we have 1, 2, 3, 4, 5, which is 5 there. And then we're going to say I is equal to, so I is equal to the initial starting value. In this case, we're starting at 1. Then we're saying I being the function of what we're adding. You get, right? So over here, you can just think of it as f of I. But in this case, f of I is just equal to I itself. That's what we're just saying. So if I starts at 1, we're going to add 1. Then we move on to the next one, which is 2. So 1 plus 2. Then move on to the next one, which is 3. So plus 3 plus 4 plus 5. So it's a shorthand way of writing these summations. Then say we had another summation where we wanted to say the sum of the first n odd numbers, right? So you can say 2 plus 4 plus 6 plus 8 plus 10, right? So over here, we still have 1, 2, 3, 4, 5. But remember, how do we represent our even numbers? Even numbers are represented by saying 2 by some integer. In this case, let's say I, right? So if I say this is my I is equal to 1, it gives me 2. I is equal to 2, it gives me 2 times 2, 4. I is equal to 3, 2 times 3, 6, 4, 8, 5, etc. Right? So in this case, our function of I, right? Our function of I is going to be equal to 2I. So our formula now is going to be, for this specific summation, it's going to be 5, our symbol there, starting at I is equal to 1. Then our function of fi, in this case, is just 2I, right? Which can then be represented as 1 as 2 plus 4 plus 6 plus 8 plus 10, like that, right? So we have this over here. Basically, this is how you can represent this summation over here, right? Now, say you don't know how many you want to sum up, right? So I'm just going to maintain the same one that we have over here. So say this summation continues plus dot 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 plus n, right? So it goes up to the nth term, right? So it goes up to, let's say, 2n, because remember our function is 2n, so this is n here, right? So how do we represent this? Well, our final term here is the n over here, right? So we say our summation symbol n starting at I is equal to 1 over 2I. So we're moving from I is equal to 1 all the way to n in increments of 1. That's what we're going to have. Okay, so 2 by 1 plus 2 2 by 2 plus 2 by 3 plus 2 by 4 plus dot 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 plus 2 by n, which is what we have over there. So this is just a basic overview of summations. So in the next part of this, we're just going to quickly go over how we can actually extract certain formulas for ourselves. Yeah.